and welcome to another video. Today it's Advent of Code. It's that time of year again, and I really want to see your solutions, so leave those in the comment section down below. If you want to support the channel, there is a link in the description to different affiliates where you can get great deals on things, and there's also a donation link if you want to donate a coffee to me in order to improve the quality of this channel. Day 3. Mull it over. Our computers are having issues, so I have no idea if we have any chief historian in stock. You're welcome to check the warehouse though, says the mildly flustered shopkeeper at the North Pole Toboggan rental shop. The historians head out to take a look, and the shopkeeper turns to you. Any chance you can see any of our computers are having an issue again? The computers appear to be trying to run a program, but the memory, your puzzle input, is corrupted. All the instructions have been jumbled up. It seems like the goal of the program is just to multiply some inputs, numbers. It does that with instructions like mull, where x, y are each 1-3 digits numbers. For instance, mull 4446 multiplies 44 by 46 and gets a result of 2024. Similarly, mull 123 by 4 multiplies 123 by 4. However, because the program's memory has been corrupted, there are also many invalid characters that just should be ignored. If you take a look at the part of mull instruction, like mull 4 star, mull 6.9 exclamation mark, or question mark, or mull with a lot of spaces in it, do nothing. For example, consider the following section of corrupted memory. Only the 4 highlighted sections are real multiplication instructions. Only the 4 highlighted sections are real instructions. Adding them up results in each instruction produces 161. Scan the corrupted memory for corrupted mull instructions. What do you get if you add up all the results of the multiplications? I think that in this case, a very simple pattern matching would be in order. So I've prepared already here. So let's take this, and I think there will only be one line. So lines get 0, string line, and then we need to have a pattern. We can call that pattern compile, and the pattern should be here, mull, and then parentheses, and then we should have some amount of digits, and then there should be a comma, and there should be some amount of digits again. And that's the only thing that we allow. So while matcher, or we can take a matcher, m in pattern match this line, and then we take while m finds another one. We will take, let's see, we have the 2 values here. We will put those into groups. And then we will say that these are part of the pattern, like that. Or should we do like that? Oh, they need to be double dashes. So those are a part of the pattern. And then we will have parentheses that saying these are the 2 numbers. So if we find something, then we'll take group 1. And then this should be an integer. Integer parse int of group 1. And this is value 1. And then the actual data, val2. So let's take the test as well here, and they should be day 3. And then we have long result. Result plus equals val1 times val2. So let's see if we can take result, print that out. What's the problem here? Yeah, we will cast that to a long, that's fine. Run current file. We get 214, that's not correct. No, we didn't take the second one. So let's, 161. So now we got the right value there. And if we take the other one, we get a larger value. Let's see if this is the correct value. Put that in here. No, your answer is too low. So maybe these values are just too high. So let's do our big integer example again here. Result equals to result add, and then we have big integer value of val1 multiplied by big integer val of val2. So let's hope that this will give us a different answer. No, it gave us the same answer. And that was too low. So let's do that for string line in lines, and that and that, then we should get a much bigger result, of course. So that's a big result. Let's see if that's the correct one, because the math seems pretty reasonable. Yes, you get a gold star, I get a gold star, everybody gets a gold star. So we got the first one at least. Part 2. As you scan through the corrupted memory, you notice that there are some of the conditional statements that are also still intact. If you can handle some of the corrupted conditional statements in the program, you might be able to get an even more accurate result. There are 2 new instructions you need to handle. The do instruction enables future Mull instructions. The don't instruction disable future Mull instructions. Only the most recent do or don't instruction applies. At the beginning of the program, Mull instructions are enabled. For example, don't do. This corrupted memory is similar to the example from before, but it's time the Mull and instructions are disabled because there is a don't instruction before them. The other Mull instructions function normally, including the one that ends in re-enabled by do instructions. This time the sum result is 48. Handle the new instructions. Can we do this with this pattern that we created before? So we continue here. So this could be one thing, right? And then we could have a do with parentheses, and we could have a don't with parentheses. And these could also be instructions that we could find down here. So if we do like that, we will get a different grouping for group 1 So just system out the first group like that, and we use the test. What do we get? We get null, 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 0. Ah, okay. So we have a different test input. That's the problem. So we are finally using a different test input. That's why. So if we go back here and we remove the first part here, so we just do a do don't, and we say that we want to do part B. And then I will need to copy our input data to B as well, because we will use the same input data there, I guess. So here we got do and don't. Yes. So now we got all the information we need. So if do is the first one, if group 1 is not null, then we have a boolean here, enable equals to true, and then we will do true here. If group 2, the don't, then false. Otherwise, if group 3, and enable, we will print out. Then we will just get 2 Mull exceptions, and it's those 2 that we want. So we have the right kind of logic here, and then we will in this third group take group 4 and 5, which is the inner parenthesis of this grouping, and then we get the result of 48. So that's the result here. Now if we do the same here, but we say that we don't run with the test, what do we get? We got that large number, and it's smaller than the other number, so probably correct. No, your answer is too high. Wait a minute, from the beginning of the program, I put the enable inside here. That's not correct. So this should be correct. Yes, now we got a much smaller number. Let's try that out. Yes, you get a gold star. I get a gold star. Everybody gets a gold star. So day 3 was not that complicated as long as you can do patterns. So patterns helped us a bunch here, and I think the pattern could actually be up here, just to simplify it a bit. But let's look at what we actually did here. So first off, we have this function where we read in the lines, and we had a different part B and part A when it comes to the test data, so that we need to keep in mind. Then we created this pattern where we first off in the first parenthesis say that we could have a do statement, and then we say or we could have a don't statement. And the really important part here is that we need to escape the parentheses, because these are a part of the data, not a part of the actual expression. And then or we could have a multiplication expression, which is here. And inside of that we have 2 more parameters that could be 2 digits. So we have 5 different parameters in this expression. Then we start a big integer. We start at 0. We enable. We are enabled, so we will multiply things. Then we go through each line. We have a matcher pattern here of that line. We will find the first group, which is the do, and then we will enable. We find a second group, then which is the don't, then we disable. And if we find a third group, which is the multiply, and we are enabled, we will fetch the two values and we will multiply them and add them to our result. So this was not that much code, and it's pretty clean, pretty easy to understand if you understand how to write these regular expressions with patterns. That's the hard part here. I hope that you found this interesting. I hope that you learned something today. If you have your own solutions, I love to see them in the comment section down below. If you haven't subscribed yet, please do that. If you like this video, give it a like, share it with your friends and colleagues. And I really hope to see you in the next video.